Let's go to number 5a. The function f is given by f of x equals 3x squared plus 10 over x squared minus 4. X is all real numbers. X is not equal to 2 and x is not equal to negative 2. Prove that f is an even function. For even function, we do know f of negative x equals f of x. So f of negative x equals every single x we will turn into negative x. 3 times negative x squared plus 10 over negative x squared minus 4. So we have 3x squared plus 10 over x squared minus 4. This equals f of x. So f of x is an even function. The graph of even function will reflect across the y-axis. For 5b, sketch the graph y equals f of x. So we need to use this property. For vertical asymptote line, we have x equals 2 and x equals negative 2. For horizontal asymptote line, we will get y equals limit 3x squared over x squared equals 3. So y equals 3 is a horizontal asymptote line. X-intercept 3x squared plus 10 cannot be 0, so no roots. For y-intercept, f of 0 equals 10 over negative 4. That is negative 2.5. Let's draw the sun diagram. Vertical asymptote line. Then horizontal asymptote line. Y equals 3. X equals negative 2. X equals 2. We don't have roots. So we find a number. Let's use 0. We plug into this function. Basically, we already figured out f of 0. That's a negative. This interval is a negative. Since the factors are single factor, we need to change the sign. Positive or positive. So we can predict the graph. This interval is a positive. Graph will be like this. This is a negative. So the graph like this. This interval is a positive. Graph like this. We do know this function is an even function, which means the graph is reflected across the y-axis. In other words, this is a y-axis, and at this point, 0, negative 2.5, so that the graph will be reflected across the y-axis. Now let's sketch the graph based on the sun diagram. Label the x, y, and origin. X equals negative 2 is a vertical asymptote line. X equals 2 is the other asymptote line. So y equals 3 is a horizontal asymptote line. Negative 2.5 is the y-intercept. So we sketch the graph like this. This will be the graph for f of x. For 5c, write down the range of f. From the graph we sketched, we could say y less than or equal to negative 2.5 or y greater than 3. Let's go to 6a. Express x squared plus 2x minus 3 in the form x plus h squared plus k. We have a equals 1, b equals 2, c equals negative 3. So h equals negative b over 2a equals negative 2 over 2 times 1 equals negative 1. And k equals, we plug negative 1 into the function, you will get negative 1 squared plus 2 times negative 1 minus 3 equals negative 4. So the vertex form will be x plus 1 squared minus 4. The vertex is negative 1, negative 4. For 6b, factor x squared plus 2x minus 3, it will be x plus 3, x minus 1. 6c, consider the function f of x equals 1 over x squared plus 2x minus 3. Sketch the graph f of x indicating on it the equation of asymptotes, the coordinates of y-intercept, and the local maximum. For 1 over x squared plus 2x minus 3, we will factor, you will get 1 over x plus 3 times x minus 1. We need to draw the sign diagram before we sketch the graph. We need to figure out the roots. Since 1 cannot be 0, so no root. For the vertical asymptote line, x equals negative 3, x equals 1. For the horizontal asymptote line, we will use a limit. As x approaches infinity of f of x, we will use 1 over x squared. That equals 0. For y-intercept, f of 0 equals negative 1 over 3. Let's sketch this sign diagram. We have negative 3. This is 1. Vertical asymptote line. And y equals 0 is a horizontal asymptote line. We will use number 0 to decide the sign of this interval. Since f of 0 equals negative 1 over 3, the sign for this interval will be negative. Then check the factor. Since the factor we have is a single factor, we need to change the sign for the neighbor interval. So this is a positive, this is a positive. Then we can sketch the graph like this. Positive will be this. Positive. Since for this interval, the sign is a negative, so we can sketch the graph like this. What's this maximum point? We know for the denominator, x squared plus 2x minus 3. The vertex, that's minimum, is -1, -4. Therefore, from -1, -4, we will get a maximum of f of x will be -1, -1 over 4. Now we can sketch the graph. So we know this is x, here is a y, origin. This is x equals -3, x equals 1. Vertical asymptote line. Then the horizontal asymptote line, y equals 0. The graph like this. This side like this. The y-intercept is a -1 over 3. It's here. And -1, -1 over 4, it will be here. Let's sketch the graph. Don't forget label the coordinate of y-axis. That is 0, -1 over 3. And for this maximum, -1, -1 over 4. Let's go to 6D. Sketch the graph of absolute value of f of x. Absolute value of f of x, which means when f of x greater than 0. Absolute value of f of x will be f of x. So above x-axis will stay. And the graph below x-axis will reflect across the x-axis. So the graph will be like this. For 6E, sketch the graph f of absolute value of x when x greater than 0. F of absolute value of x equals f of x, which means the graph on the right side of y-axis will stay. The graph on the right side of y-axis will stay, then reflect across y-axis. Don't forget the vertical asymptote line also reflect. So the graph will be like this.